Okay, well, welcome to section 8 of chapter 8, and this will cover complex numbers. Very, very important idea in mathematics. And up until this point, all the numbers that we have talked about have been real numbers. But now we're going to extend that a little bit. So remember we were once talking about the square root of minus 4 or the square root of minus anything. And we said there is no number such that when you multiply it by itself, it turns out to be negative. And really what we should have said is that there's no real number. So what we do here is we make a very important definition. And what we say is that the square root of minus 1 is equal to this number called I for imaginary. And what that means then is that I times I is minus 1. So it's important to note that I is not a real number. No real number can be negative. But I is a number that has the property that I squared is minus 1. That is pretty weird. Well, if I squared is minus 1, then I cubed, which is I squared times I, must be minus I. And I to the fourth, which is I squared times I squared, is minus 1 times minus 1, which is 1. And then I to the fifth is just I to the fourth times I, which is 1 times I, which is I. And we're back again. So there's a nice cyclical pattern in fours for powers of I. I is either going to be 1. Whoop, this should have been minus I. I knew I made a mistake there. So you're either going to get I, or minus I, or 1, or minus 1. So let's just do that again. I squared is minus 1. I cubed is minus I to the fourth is 1, and then I to the fifth, we're back to I again. So here is one full cycle of 4 for the powers of I. So this is the formal definition of a complex number. A complex number is of the form a plus bi, where a and b are real numbers, and I is the square root of minus 1. So what we can look at then, maybe some more interesting powers of I. So we showed that I to the fourth is 1, I to the eighth will be 1, I to the 12th will be 1, I to any multiple of 4 will be 1. So I to the 35 I can write as a multiple of 4, and then what's left is a 3, and if you remember, that's equal to minus I. This is 1, and I cubed is minus I. I to the 58th. Well, the biggest multiple of 4 less than 58 is 56, and then I have an I squared. So this is just going to be 1, and then I have I squared, which is minus 1. So that's how powers of I simplify. They'll always be 1, minus 1, I, or minus I. Kind of fun to play with them. And the whole trick here is to always get them so that we have not a multiple of 4. And I to any number which is a multiple of 4 will be 1. So let's look at some of the operations that we might have with complex numbers. And again, this is all about like terms. So for example, if I have 3 plus 5i, and I'm adding, let's say, 7 minus 2i, you can probably guess what the answer is, right? Add the like terms, and you get 10 plus 3i. Okay? So it's hardly worth your time, but if we're doing subtraction, The only thing here is you got to make sure that you remember that when you have a negative and a negative, it becomes a positive. And so this is going to equal minus 4 plus 7i. Right? So adding and subtracting complex numbers, no big deal. So how about multiplying? Well, if you take a look at these, really what applies here is FOIL. So the first terms give us 6. The outside terms give us minus 9i. The inside terms plus 10i. And the last terms minus 15i squared. Now, let's remember, this is the big deal and this pops up all the time. I squared is minus 1. So this then simplifies to 6 plus I plus 15, right? We have a minus times a minus. And so finally my answer is going to be 21 plus I. So multiplying two complex numbers really and truly is all about FOIL. So let's look at another example or two. Something like this is always going to screw you up unless you remember that this should be written as 3 minus 4i times 3 minus 4i. And now if we use FOIL, we get 9 minus 12i minus 12i plus 12i squared. And it's going to show up every time. We have to remember that I squared is minus 1. So now when I add together my like terms, what I'm going to get is, here's a 9, here's a minus 12, so that's going to give me minus 3, and if I add the two I terms together, I get minus 24i. Okay, so there we go for the multiplying. And now let's look at what happens when we divide two complex numbers. So this is about as simple as it could look, just 5 over 2i. And just like with radicals, I, remember, is like a radical. It's the square root of minus 1. And the rule here is we don't want I in the denominator. So we're going to rationalize. And this should be sort of familiar to you. So I'm going to multiply top and bottom by I. What that gives me is 5i over 2i squared, right? I squared is a minus 1. So this is really just minus 5i over 2. And we've simplified the bottom in the sense that we no longer have an I in the bottom. Okay, so we'll continue looking at these, and they're going to look a lot like rationalizing the denominator with the radicals, and we have the same concept with the conjugate. So here we go. Alright, so here's an example of one full complex number divided by another one. And we want to rationalize the denominator. In other words, we want to multiply top and bottom by something to get rid of the I in the bottom. And it's just like with radicals. So, in fact, we use the same phrase, same term. The conjugate of a plus bi is, what do you think? A minus bi. And what I'll do here is multiply top and bottom by 2 plus 7i. 2 plus 7i. And when I do that, why don't you press pause and see what you get when you multiply these things out and combine like terms. So this is what you should get. And to truly write that as a complex number in the form a plus bi, I would write it as minus 29 over 53 plus 31 over 53 times I. Let's just go back for a second to talk about the conjugate. The whole reason why the conjugate works is if I take anything like a plus bi and multiply by its conjugate, right? This is of the form x plus y times x minus y, and when you multiply you get x squared minus y squared, and so when you multiply this out you're going to get a squared minus b squared I squared, which is the same as a squared plus b squared. And so when you multiply by the conjugate, it eliminates the I term. Alright, so that's the importance of multiplying top and bottom by the conjugate of the bottom. So here's the last property of complex numbers. It's not true in this case that this is equal to the square root of minus 6 times minus 8. That property only works when the numbers under the radical are positive numbers. And so the way that we have to work this is we rewrite this as the square root of 6 times I times the square root of 8 times I, which gives me the square root of 48 times I squared, which is the square root of 16 times 3 times minus 1, which comes out to be finally minus 4 square root of 3. So it's important to remember that this rule that works with positive numbers does not work with negative numbers. And that finishes up complex numbers, and that finishes up chapter 8. So hope you're doing well, and we'll see you back here when you get ready for chapter 9. Ciao, ciao.